picking up good vibrations.
So in this video, we'll talk about a few concepts of calculus that you should know already, so just a matter of recapping. The first one is the sum of a geometric series. So we have the sum from k equals I until L of alpha to the power of k. That will be equal to alpha to the power of I, the first term, alpha to the first term that we have here for k equals I, minus alpha to the power of the first term that you haven't added. So that the last term is alpha to the power of L, so the next to it that we don't add is alpha to the power of L minus plus 1. It's alpha I minus alpha to the power of L plus 1 over 1 minus alpha. Now, if we take the limit as L goes to infinity, if we consider k equals 0, so basically if we consider this summation here, we can just simply conclude from this formula, if we replace I by 0, and we get 1 here minus alpha to the power of L, where L plus 1, where L goes to infinity. And if alpha is less than 1, that will be 0. We get simply 1 over 1 minus alpha. It's a formula that we use very often, and it's actually derived in the background material, also a video on that here, for a more general case where alpha is a complex number. Then we have the fundamental theorem of calculus. It tells us that if we want to take the integral of a function f, and if we know a primitive, that is a function g, such that when we differentiate, that gives us f. If we want to take the integral from 0 to b of f of t dt, that is equal to the primitive evaluated at b minus the primitive evaluated at a. Then we have integration by parts. That basically tells us if we want to compute an integral of a product of two functions, f and g, and if we know a primitive of the first one, we know h, such that when we differentiate, we get f. The formula for the integral of this product, the integral from a to b, is nothing more than the primitive of f, h times g evaluated at b minus the same function h times g evaluated at a, minus the integral from 0 to b of h times g prime. So we have to differentiate g and take that integral. We also look now at improper integrals and sums and integrals of functions of two variables. So we're now going to talk about improper integrals, and that basically means an integral whose limits of integration, either one or both of them, is plus or minus infinity. And that is basically very simple. What we mean when we place an infinity here is that we're taking the limit of this integral, which is an integral that we already know quite well, when this limit of integration, in this case b, goes to plus infinity. And so basically, as an example, if I tell you to compute the integral from 0 to plus infinity of e to the power of minus t dt, you can do the following. The limit as b goes to infinity of the integral from 0 to b e to the power of minus t dt. You compute this as usual. You have to take the primitive, e to the power of minus t between 0 and b, which is nothing more than minus e to the power of minus b minus 1. And basically, then once you compute this, you just take the limit as b goes to infinity. In this case, this limit is 0, so we're left with 1. We can also have, and we'll typically have in our course, the integral from minus infinity to plus infinity of a function. And that basically has a very similar meaning. We can just simply compute the integral from minus b until b of that function. That's something that we can easily do. And once we're done with that, we take the limit as b goes to infinity. Now, let's look at sums and integrals of functions of two variables. Suppose first that I have a matrix, a discrete function of two variables, k and l, and it's represented here. And I want to add with just respect to k. I want to fix L and add with respect to k. So this will give me a function of L. How do I obtain this function of L? I can plot it here. Once I fix L to be equals 1, I just have to add the terms. For L equals 1, I add these three terms with respect to k. 1, 2, 3, that gives me 6. Here I get 0, 1 minus 2 gives me minus 1. And finally, here I get 10. So O tilde of 1 is 6, O tilde of 2 is minus 1, O tilde of 3 is 10. Why am I talking about this? Because very often in signals, we're going to have a function of two variables, and we're going to take the integral just with respect to one of the variables. For instance, the Fourier transform is going to be defined as a function of two variables. It's going to be the signal times e to the power of minus j omega t. It's a function of t and omega, and we're going to take the integral, improper integral, with respect to t. And once we do this, we're going to get a function of omega. Just as an example, if we have a function of two variables, e to the power of t plus 2 omega, and if we take the integral from 0 to 1 of this function with respect to t, we will get e to the power of 2 omega times the integral from 0 to 1 e to the power of t dt. And once we compute this, this is e to the power of 1 minus 1. We get a function of omega.